right, we're doing this problem called binary tree maximum path sum. Let's have a read. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. Okay. The path sum of a path is a sum of the nodes values in the path. Okay. Given the root of a binary tree, return the maximum path sum of any non-empty path. So in this case, 1 to 3, the optimal path is 2, 1, 3 with a path sum of 2 plus 1 plus 3. Looking at this, okay, negative values can be there, so you wouldn't want to include this guy in the path, I would assume. So my one question is, can a single node be considered a path? I guess so, right? I guess 1527 would be the largest path, okay? So let's try and solve this problem. So essentially, we have to find the maximum path sum, right? Or the path with the largest sum, and know that path may not necessarily go through the root of the tree. And obviously, the second example, which made it more clear, let's replicate it here. So it was one sec. All right. So minus 10, 9, 20, 15, and 7. So the maximum path in this case is just this. Okay. How can we find? So essentially, that means is, well, the maximum path will go through some node as a root, right? Like you can't say the maximum path does not go through. I want to read the path again. What's the definition of path? Does it go till the leaf or node? The path sum is the path of node values in the path. A path is a binary tree in a sequence of nodes. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in a sequence at most once. Note that the path does not need to pass. My question is, so this is my question. In this array, in this tree, if there was a minus 100 here, then can I consider this as the path? That's my first question, which I am not sure what the answer is. Uh, right, in that case, I wouldn't want to consider minus 10 at all. Like one way it is clear, which is that the path does not necessarily have to go through the root, but does the path have to terminate at the leaf? Who can clarify? So maybe I put in this as an input. Okay, let's go to the code. And here what we can do is I return let's say some garbage, return 0, and I give this test case as an input to see what what's the answer. So nice thing is it's also building the tree for me. So yeah, so maybe this is the one. Now null 15 and 15.7 was fine. So minus 10's 920, and then okay, null, yeah, whatever. So 15.7, null, null, fail to parse your input. Why, man? Okay, let's give comma, null, null, maybe because of the comma. Okay, and then minus 100. Yeah, so no. So maybe hold on. let me let me see. So minus 10, 9, 20, and then null. Yeah, null, 15.7, and then minus 100. Okay, you just have to give minus 100 right away. Yeah, so in this case, what is the maximum path sum? Like, could I just take like 15, 20? So let's run. And it's the second thing. And the output is expected is 42. So 42 is 15. Yeah, so if I go to the tree, it doesn't show the tree now, but yeah, so 42 is 27 plus 15, right? So it was able to handle that scenario. It was able to handle that scenario. Okay, so it does not necessarily have to end at the root. Okay. All right, then uh, confirming. So rest case, yeah. So in this case, you get 42 by considering 20, 15, and 7, and that's it, right? Okay, so that's clear. Now let's come back to the whiteboard. So this is a good example input, and the maximum path sum then just becomes uh, just 20, 15, and 7. Now how can we solve for this? Hmm. Your task is finding max path sum set of connected nodes. I feel there is some relationship. So for example, if I start from the leaf nodes, right? Let me build this tree again to get more clarity. Oops. Uh, so it's minus 10, 9, 20, 15, 7, and minus 100. Okay. Now let's look at this tree, and let's start with the each of the leaf nodes. So for this leaf node, that leaf nodes means will not go above it. So for this 9, I know the maximum subtree sum, maximum path sum for its subtree is 9. For this it's 100. For this it's 7. So these leaf nodes are quite clear. So for 15, basically I'm looking at trees rooted at this, right? So for 15, the maximum path sum that I will get is either just 15 or 15 plus sum. Okay, so here in this case, this will only amount to 15, right? So this was 9, this was giving me minus 100, this is giving me 15, this is giving me 7. So for 20, what will I get? So for 20, again, there are three options. One would have been just 20, other option would have been 20 plus 15, one option would have been 20 plus 7, other option could have been consider all, right? 20 plus 15 plus 7, which is 42. So whichever is the maximum of all of them. So in which case 42, I get this 42. And then what for minus 10? So again, for minus 10, this guy has multiple options. One option you just consider minus 10. Other option is you consider minus 10 plus just the left, or you just consider minus 10 plus, because if you consider value for 20, you don't have to go back because all of that is already considered. So for if I look at 20 and below, the maximum that I can get is 42. I already know that. So 42, or you consider both, right? So it all depends upon whether the left is giving me negative value or positive value. If it's positive value, I'll just probably want to add all positive values. But if, let's say, if it had been minus 9, then I wouldn't want to consider this minus 9, right? So let's say this is minus 10 plus minus 9, this is minus 42, or minus 10 minus 9 plus 42. So in this case, obviously the max that I'm getting, including 10, is minus 10 plus 20. So essentially, uh, this, right? So we get the gist. So for every node, uh, max path sum is equals to max of multiple things. One is self, right? Or self plus max path sum in left, or self plus max path sum in right, or self plus max path sum left plus max path sum right, right? All of these different cases, and you have to build like up. So first you have to do get the max path sum for the. So basically you have to do left, root, and then right. Sorry, left, right, and root. So you have to do like a post order traversal and build the values for each and every child, and then update the value for the root. I think we got the idea. Let's come to the code. So essentially what we're saying is that not we don't return 0, obviously. So we obviously want to maintain a max, right? And we initialize this value to what is the value supported of the integers? Okay, -1000. So let's give it some large negative value. Integer dot main value, and this is what we will return at the end. But we want to be able to maintain max of left and max of right, which we will get as a return value from thing. Okay, so now we want to do is okay. So but let's maintain max here then. Okay, int max. Oh no, this is fine. This is all good. Yeah, I think that's it. Keep maintain max here. Okay, so int max, and then you do this and do this, and then you call return, or not return, just a function. So a max path sum. You pass root. Anything else? Not really. Okay, so we call it max path sum util, and you do void max path sum util tree node of root. Now, if your root is null, just return 0. So that means that you can initialize your max to 0 as well, right? You don't take any node. Okay, so you return 0, and otherwise, uh, like we saw, there are multiple different cases. Uh, so first you want to get the max path sum of root, and so int max path sum left, mps left, equals to max path sum util of root dot left. Let's also get this value for right. Let's call it mps like that only. So max path sum left, max path sum right equals to max path sum util of root dot right. What else? I think that's it. So now um, let's call it mps. So mps equals to max dot max of multiple things, right? So we initialize, let's say, mps with the root dot val, and then we'll do mps equals to math dot max of mps comma uh, root dot val plus mps left. That's one option, and then other option is root dot val plus mps of right, and the other option is root dot val plus mps left plus m. Right, so this is the answer for maximum path sum rooted at this node, and we were maintaining this max equals to math.max of max comma mps, and what we are returning, you should be returning, okay, so max, you should return an int here, and what you're returning really is the max path sum containing this root, or rather rooted at this node, so which is what you want to return for this recursive, for these recursive calls, right? So you, and you return mps. Okay, so that's my logic. Let's run the code and see if there are compilation or logic issues. There is wrong answers, but they compiled. Okay, so you get 0 but expected was 6. Root.val will decide, will make it non-zero. Now you call root.left, you call root.right. Let's quickly do walkthrough for the first example. So you go, okay, because you call it int here, so it returns local variable, not the global one. Okay, run again, and it works. Submit, and you get a wrong answer for -3. Ah, okay, so -3, it says your output 0 but expected is -3. So you cannot, all right, then basically then it says that you cannot, this is interesting. Um, you have to take a value from a node. Like you can't take no nodes, non-empty path is not allowed. So this max that I'm defining as 0, I'll change it to integer dot max value. And what then I'm gonna do is I will update this max only if, by the way, if root is null, I'm just returning. So that means root is not null, and root is not null. That means I have to consider, and so that is fine. I think that is sufficient. So let's run this as a test case. Okay, use this as a test case and run, and everything fails all of a sudden. What did I? What, oh, I got it. Integer dot to take main value. Okay. All right. Submit. What happened? So something wrong again? Okay. Let's see what happens here. 45 expected is 48. Let's quickly um, use this as a test case. So this is the tree. Everything is positive. So ideally I should just take everything, sum of everything, right? That will be my path. Is it? Ah, I think you messed up. So when you're saying a path, like for interesting. So for 11, it made sense that you could take both left and right. So 7, 11, 2 is what you got. But when you want to solve for 4, you can go, you can either take left or you can either take right. You can't have like 4, 11, 7, 2 as a path, right? That's not a path. The path will either be 4, 11, 7 or 4, 11, 2. So you'll have to maintain a max. So there are two things that you have to maintain then, right? Interesting. So one of the things that your return, what you return to your parent is whatever is the maximum that the parent can use, which will be itself or itself with one of the childs, right? And for the max, yes, for the max you calculate itself with both child as well, but that would be for the case when you're considering the max. So there are two cases. One is you have to update it a little bit. So you don't return MPS, you return something else. You return what is uh, okay, you return max of these three. Okay, so let's define them. So one is I don't know what to call them, but I'll call it MPS with one child, max path sum with uh, one child, right? Okay, or not. Let me see what to call them. Max path sum prefix. I'll call it MPS1. So MPS1, 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 and I will be returning MPS1, while MPS2 will be either MPS1 or this, right? So this is what I have to return to the parent. Like this clarifies, this example clarifies it. Like I want to return 11 plus 7, 11 plus 2, or 11 to 4 because that's what 4 can use, right? But when I'm looking at the total path, I can consider both childs as well, just for returning it overall max. So that's the case here. Now let's run. Get a compilation error. Uh, okay, MPS1, MPS1. Let's run again. Okay, it won't know what this is. So let's fix that. Run. Okay, now submit again. And it works. All right.